Okay, so welcome to the first of our video tutorials. Today we're going to be going over some basic algebra that you'll be using in this class. Calculators, how to use the graphing calculator, scientific notation, significant digits, and some trigonometry. So, to get started, we're going to go over some math basics. Now, I was taught PEMDAS, okay, and some of you might have been taught, please excuse my dear Aunt Sally, whatever way you were taught orders of operations. What's important is that when you are solving for equations for a certain variable, you have to work in reverse order of operations. And what that means is that if the subtractions come up, you have to deal with that first. If there's addition in the problem, you have to deal with that first. In this case, if I'm trying to solve for M1, there is a division dividing by r squared. So I have to deal with that dividing by r squared. So the opposite operation as dividing by r squared is multiplying by r squared. So if I multiply both sides by r squared, that cancels out the r squares on the right-hand side. So I get r squared times f of g equals g times m1 times m2. So now I could deal with the multiplication. So what I'm going to do is I'm going to divide both sides by gm2, gm2. The g cancels out the g up there, the m2 cancels out the m2 there, and so I get a quantity that's solved for m1. So m1 equals r squared times f of g divided by g times m. The next example is solving for the variable r. So once again, I'm going to work in reverse order of operations. And the first thing I got to do is once again dealing with that division. And the step is actually the same. I'm going to multiply both sides by r squared. Okay, that cancels out the r squares on that side. So I get r squared times f sub e equaling k times q1 q2. So now I can deal with the multiplication. So the opposite of multiplying by f sub e is divide by f sub e. And that cancels out the f sub e's on that side. So now I get this part, the k q1 q2 over f sub e equaling r squared. And now I could deal with the exponents. Okay, so the exponent part. So the opposite operation of squaring is square rooting. So if I square root both sides, I end up getting my answer, that r equaling k times q1 times q2 divided by f sub b, and the square root of all of that. The last example here for the algebra is solving for the variable vi. Okay, so vi stands for initial speed or initial velocity, and so this case we have to kind of be careful because we're not just jumping right to the division or multiplication. We have to deal with the addition. So if I'm trying to get vi by itself, the opposite of adding 2ad is subtracting 2ad. And whatever I do on one side, I have to do the other. So 2ad minus 2ad cancels, and I get vf squared minus 2ad equaling vi squared. So then I can get to the exponent part, and the opposite of squaring is square rooting, and so my vi equals the square root of vf squared minus 2ad. Now, calculators are a big thing in this class. Knowing how to use your calculator is going to be extremely important. I have a simulated TI-83 that I'm going to share with you, but whatever scientific calculator that you have, make sure you know how to use it. So the TI-83 looks something like this. Okay, and so I'm just going to put this alongside here. And if I wanted to take the number 2 times 10 to the second and multiply it by 4 times 10 to the minus 4, okay, what I'm going to have to do without exponential notation, I'm going to have to write it as 2 times 10 to the caret 2 times 2 times, excuse me, 4 times 10 to the minus 4 to the caret minus 4. And so that would look like on the calculator like this. And notice that I'm including parentheses around everything, and that's going to be the real drawback of going with this method. Okay? And so I get 0.08 if I do it that way. If I do it in exponential notation, I'm going to use this button, the EE button. And so the EE button, okay, on your calculator is right above your comma. So I'm going to type in 2 second, comma, and that gets me the E to the second times 4 second E to the minus 4. And notice that this has fewer, I had to type less values. Okay, I do not need to include the parentheses. And I also get an answer of 0.08. So either way, I get 0.08. However, I had to do a lot less typing with exponential. This is going to be the method that I'm going to suggest you all get used to. If you're unfamiliar with it, it is a little to get used to, but once you're used to it, it's pretty easy to work with. Scientific notation. When you're dealing with a value that's very large, it's not easy to work with large numbers. So scientific notation comes in handy when you're dealing with the very big and the very small. So if I have large numbers, what I need to do is move that decimal to the left. In other words, this value, 3,750,000, the decimal point is in between the last 0 and meters. So if I wanted to make this in scientific notation, I move it all the way over, okay, after the 3, after the 7, but before the 3. So I write 3.75, and I counted 6 places that I moved it over. And since I'm moving to the left, it becomes a positive power of 10. So that's 3.75 times 10 to the 6th meters, since I counted 6 spots. Small decimals, you have to take the decimal and then move it to the right. Okay? So, and that would become a negative power of 10. So I write this one as 4 times 10 to the minus 3 meters, since I moved it over to the right 3 places. So we can work out the rest of these. Okay, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. So that's 9, 11. So I have 1.5 times 10 to the 11 meters. Talking about distance. A length. Now this is a number less than 1. So I'm going to be moving the decimal to the right. And I'll be moving the decimal to the right 6 places. This becomes 6 times 10 to the minus 6 meters. A few more. This is starting over here, 1, 2, 3, 1, 2, 3. So that's 6 places. However, and we'll talk more about this, you preserve the number of significant figures. So 9, 0, and 7 are all significant figures. So we want to keep them in and make it a positive 6 since we moved it to the left. Last one, since we moved this over 3 spots, 1, 2, 3, in front of the 5, this would be 5 times 10 to the minus 3 meters per second. Significant figures, okay, or sometimes referred to as digits. You'll hear me say both of them because they kind of refer to on the Regents as both. I like this flow chart. This kind of takes all the rules and simplifies it to just follow the flow chart. So if you're unsure, follow the flow chart. So if you ignore all leading zeros, a leading zero would look like this right down here. All of those are considered leading zeros. Okay? And if there's a decimal point, if there isn't a decimal point, okay, go to the right. Count all remaining digits, okay, except for trailing zeros as significant. If there is a decimal place, and the decimal place can be anywhere in the number, then count all remaining digits. So, okay, is there a decimal present in this first example? Okay, no. So all I do is count all remaining digits except these zeros. These are considered trailing. They fall after the non-zero digit. So this would just be 3 significant figures. These are leading zeros, so I'm going to ignore them. There is a decimal present, however. Okay, so I count all remaining digits. So this would be 2 sig figs, and 9 and 3 are significant. This one, okay, I have a decimal point, okay, but I do have a trailing zero. But since the decimal place is present, that zero, someone said they measured that, and they are sure of that zero. So this would be 4 sig figs. Here, there is no decimal place, okay, so we'd have to go to the no side. However, this zero is not trailing. It's in between. So that zero counts, so we have the 8, the 5, the 0, the 6, and the 7, all as significant. In other words, 5 sig figs. Here, the decimal is present, the 0 is in between, okay, so we count it. Okay, the 0 before doesn't count, so this is just 3. Okay, and if you're stuck anywhere along with the significant figures, significant digits, okay, refer this to the flow chart. And if you have any questions on this, please come let me know, and we can certainly, work through it. Last on our tutorial here is a little bit of trigonometry. Okay, so the definition of a right triangle is a triangle that contains a 90-degree angle. And you may have remembered your trig functions as SOHCAHTOA, that is sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Okay. The Pythagorean theorem, a squared plus b squared equals c squared. Okay, and then some of you like the law of sines. Okay, side A over sine of A equals side B over sine of B equals side C over sine of C. Okay, law of sines apply if you have a any other triangle. Okay, so this could be applied to any other triangle. Most of the time, all you need to do is your 3 trig functions and your Pythagorean theorem. So if we're working it out, okay, find the remaining sides and angles of the given triangle. Okay, so we're just trying to work this through. So let's say that this triangle has a B side of 10, a side of 5, and what we're set after to find is angle A, angle B, and C. So I'm going to start off with C, using the Pythagorean theorem, that a squared plus b squared equals c squared. That is 5 squared plus 10 squared equals c squared. And if you work that out, you get a C of 50. And so C is now 50. And now in order to find A and B, you could pick either one. I'm going to choose angle A and then go from there. I'm going to say that I'm going to use the sine function. So sine of A equals 5 over 50. And if you remember from math class, in order to undo sine times A, you multiply both sides by inverse sine. And so that cancels out my sines on this side, so I get A equals the inverse sine of 5 over 50. And if you work that out, you would get an angle of 26.6 degrees. And then if we want to find angle B, we could say the sum of the angles in the triangle is 180. So C is 90 plus 26.6 plus side B, angle B rather, equals 180. And therefore B equals 63.4 degrees. Okay, so there we solve for side C, angle A, and angle B. The next example here, we have a triangle, and let's suppose that we know C to be 15, A to be 33, and we want to find side A. Oh, sorry, and we know side A is 9.23. And let's say we want to find side B and angle B. Well, I'm going to first find side B by using the Pythagorean theorem. A squared plus B squared equals C squared. And I have 9.23 squared plus, since B is one of the legs of the triangle, in other words, not the hypotenuse, not opposite of the 90 degrees, then I have to put the unknown on this side of the equation, equals 15 squared. And so B then equals the square root of 15 squared minus 9.23 squared. And that gives me a B value of 11.8. So now B is 11.8. 11 point. And so now all we have left to find is angle B, and I'm actually going to use the same trick that the sum of the angles in a triangle is 180. So 90 plus 33 equals, plus angle B equals 180. Okay, 90 and 33 is 123, plus B equals 180. Subtract the 123, and you get a side B of 57 degrees. All right, so that's some of the basics for math. We'll talk more about it, the significant figures. We'll be using this all year. This is just to give you an overview of some of the math, or remind you of some of the math that you've used in some of your other math classes, some of the other science classes. Different parts of the year, different units will use some concepts more than others. So yeah, if you have any questions, please feel free to stop by, ask questions in class, and we'll see you next time.